Hi, this is the first part of multiplying and dividing monomials. So, your first question might be, what's a monomial? And that is a great question. So, that's also my vocabulary tool bag. Here's the definition and here are some examples of what a monomial is. A monomial is this. It could be a number, like 8. Okay? It could be a variable like n squared. Notice that the power is positive because it has to be a whole number. Or it could be a product of numbers and variables with exponents that are whole numbers. So I could have 7 times x to the 5th. So 7x to the 5th. Or I could have negative 3a squared times b to the 3rd. Also, notice all the exponents are whole numbers. So that means basically 1, 2, it could be 0, but it cannot be negative. And z divided by 4. That's okay because technically that said they say a number, so this is actually equal to 1/4, which is a number times z. So that's why that one's okay. Z divided by 4 is okay. But you cannot have, a monomial does not have an x in the denominator or a z in the denominator. After you multiply or divide, they might. But before you multiply or divide these problems, they won't start with an x or a y in the denominator. Unless they start that way. So you'll see. Okay, we have 4 examples to go through. 2 of them are multiplying, 2 of them are dividing. I'm going to do them both 2 ways, so this is probably going to be one of the longer videos. Maybe. We'll see. We'll see how I feel because I don't want to rush. This is the pivotal stuff of algebra. You really got to know this stuff. So, my first example is this. I have 2x to the 3rd power times 6x squared. Well, expanded notation for me makes the most sense to show first. So I'm going to do this. 2x to the 3rd really means 2 times x times x times x. So I'm pulling it apart. I'm expanding 2x to the 3rd out. And I'm going to also put this. 2x to the 3rd times 6x squared. Put an equal right there. Sorry, didn't mean to squeeze that in right there. So that's the first set of variables. Now let's do the second step. I have 6 times x squared. So I'm going to put 2 times, and I'm not even going to put 6. I'm actually going to put 2 and 3. I'm going to split 6 up also. 2 times 3 times x times x. Now you might wonder, why am I doing that? I'm doing that to be consistent because when we divide, that is major. When we multiply, okay, it's not too big of a deal, but it can be if they want the answer in exponential notation. I'll show you why that matters in a minute. Actually, see that right now. Think about my rules always in this. Variables are in the front, constants are in the back. When we're adding and subtracting, the same is true when we multiply or divide. Put the constants, actually I take that back, it's backwards. The constants go in the front this time. The variables go in the back. The variables are still rearranged in alphabetical notation, but this time the constants, they go in the front. So ignore that previous rule. That's for, well, don't ignore it. That's for adding or subtracting. We ain't adding or subtracting now. We are multiplying or dividing. So here we go. I'm going to do this in order. 2 times 2 times 3. So I'm doing them in numerical order. Small number first, big number after that. And all my x's, I got 1, 2, 3, 4, 5. So I have rearranged. What property lets me rearrange when I multiply? I'm going to ask you that in class. Be ready. Now I'm going to just go crazy. I'm actually going to turn this into exponential notation first before I actually finish it. 2 times 2 is, it is 4. Don't put 4. That is 2 squared times 3. And if you remember, that's from prime notation. 2 and 3 are both prime numbers, and that's the best way to go about it. Times, well, we got 1, 2, 3, 4, 5 x's, x to the 5th power, not 5x, x to the 5th power. So if the book was asking for exponential notation, you're done right here. This would be a correct answer. But let's go and simplify it all the way. 2 squared is 4 times 3 times x to the 5th. 4 times 3 is 12. X to the 5th power. And we're done. That's us going about it with the expanded notation. And there's nothing wrong with that. I actually, sometimes that's just a lot nicer to go with. Let's go with the properties. I'm going to bust out the colored pencils for this one. And you will see why in a minute. First thing I'm going to do is this. I'm going to just put my parentheses in. I'm going to put my constants, my coefficients, because that's the number in front of a variable. Remember, a number that's in front of a variable is called a coefficient. I'm going to use red for my coefficients. And then I'm going to use a different color for every variable and its exponent, so I can keep everything together. Okay, first thing, I'm not going to bother with breaking stuff apart. I'm just going to put all the coefficients in the front. So I'm going to put 2 and 6 in the front. And I'm going to put the variables in the back in alphabetical order if I have more than one. And oh yeah, you'll have more than one in a little bit. Now I treat this as if it's 2 separate problems completely. What's 2 times 6? It's 12. Yep. What's x to the 3rd times x squared? I'm going to use a... So this was an algebraic property. They're rearranging. What property lets me put two bases together that are the same and are variables? That's the product of exponents. We have 3 plus 2. We're adding the exponents together, which, hey, that equals 12x to the 5th power. Good. So that's expanded. This is with properties, and I am going to ask you to do both in class because this one's really good to do, and sometimes it's actually easier than worrying about the properties. It just depends. Example number 2. 8m to the 5th, n to the 3rd, times 4n m squared, n to the negative 8. Man, good times. Here we go. I'm going to expand this out. This is 8. Well, 8 is 2. Oh, sorry. Already doing what I did last time, aren't I? I'm going to make sure I write it down first. Hey, there we go. All right. Let's just go through the line. 8. Well, that's 2 times 2 times 2. 8's 2 to the 3rd power. Times m to the 5th. m times m times 3, 4, 5. You seeing why this method isn't that great? Why? Well, Mr. V is about to run out of room, but we're going to be okay. N to the 3rd, n times n times n times 4, well, that's 2 times 2, times m squared, that's 2m's. And then we got the n to the negative 8. It's like, man, there's already so much going on. What do we do with the n to the negative 8? Think about what I did on exponent properties, part 2. Also, I probably did it a little bit in class once or twice. I'm going to divide it. And if it's negative, I'm just going to divide with it. Well, I'm just going to put 1, 2, 3, 4, 5, 6, 7, 8 n's in the denominator. Holy cow. Next step, let's rearrange. Let's put all the constants in the front. 2 times 2 times 2 times 2 times 2. all the m's. 1, 2, 3, 4, 5, 6, 7. 7. And then 3 n's. 1, 2, 3. Divided by 8 n's. 1, 2, 3, 4, 5, 6, 7. Why did I put the n's towards the back on the denominator thing? What's n divided by n equal? Let's just do that first. This equals 1. It's gone. This equals 1. It's gone. This equals n divided by n, guys. It just equals 1. Whenever you're dividing, the next thing is to say, are there any 2's down here? No. Are there any n's up here? Not anymore. How about m's down here? No. Now we regroup. 2 to the 5th power, because I have 1, 2, 3, 4, 5, times m. There's 7 m's up there to the 7th power. N's not coming upstairs. We don't want him. He's crazy. You don't know him, man. He is nuts. N to the 8th power is staying in the denominator. We don't want him up here. He's nuts. Well, we can't leave our answer of 2 to the 5th power. 2 to the 4th power is 16. Double that. We got 32. M to the 7th, all divided by n to the 8th power. And that would be our final answer. Again, this is, I'll zoom in on it a little bit. 32 times m to the 7th, all divided by n to the 8th power. And that's a lot of work. But look what happened with expanded notation. We've got all these different variables, all this madness. And man, this isn't Sparta. This is Contra Costa Valley. So, here we go. I'm going to first off, I'm going to write these as my fancy little colors. 8 and 4 are constants. I've got m to the 5th. Are there any m's? Yeah, m squared. And I believe there is a little n to the 3rd, n to the negative 8. So I'm color coding all this stuff. The blank of multiplication, I'm going to ask you what property that is tomorrow. Lets me do this. Constants m and n, because I have 3 different colors. 8 times 4, n to the 3rd times n to the negative 8th, m to the 5th times m to the 2nd power, equals, let the magic begin. 8 times 4, 32, times m, well, 5 right there and 2 right there. What property am I going to use? The bases are the same and they're multiplying. I am going to add 5 and 2 together. Then I have n to the 3rd times plus negative 8. Because they're all multiplying, right? I'm just adding. So we got 32. M2, let's see. 5 plus 2 is 7. 3 plus negative 8 is negative 5. Can't leave a negative exponent like that. That's no es bueno. And I know sometime on a test they're going to do that, but no good. 32, m to the 7th for good. But n to the negative 5th? Nah, n to the 5th, we got to get rid of that negative. So negative 5 becomes positive 5. And n to the 5th goes in the denominator. Right. Because if I count on the other one, you might have been saying, Mr. V, there's only 8 n's, and I would have, or 5 n's, and I've been like, yeah, whatever. Yeah, that's n to the 5th over there too. Sorry, I miscounted over there. So now it looks the same. So both of them are 32 m to the 7th divided by n to the 5th. Lot cleaner, really easy to use. So now we're not using just our exponent properties. And we're not just using our algebraic properties. We are mixing them together and using all our properties. So we got to keep a handle on them. Got to know what they are. So be ready tomorrow. Example number 3. Mr. V, you didn't give me much space down there. I know. I'm going to do this. Don't worry. 39 times n to the 7th divided by 52 n to the 3rd. We basically did one of these up top with the negative, but now we're starting with division. We're taking a monomial divided by another monomial. Here we go. And because of space, we're going to put equal. 39. What times what equals 39? I can divide it by 3. And then I got 1, 2, 3, 4, 5, 6, 7 n's all multiplied together. All divided by. By the way, you better know your multiples of 13 because in poker, there are 52 cards in the deck and there are 4 different suits of 13. Got to know those 52s. And then we got 3 n's. 1, 2, 3. Parents watching at home, you better know your deck of cards too if you play poker on Friday night. Okay. At this point, it becomes divide-a-palooza. Anything that is the same on top and bottom turns into a 1. 13 divided by 13. What does that equal? 1. N divided by n equals 1. N divided by n equals 1. N divided by n equals 1. So the question becomes, what is left on top and bottom? Well, we got 3 on top and 4 on the bottom as far as constants go. But I'm not going to write 4 like that because that's going to look sloppy. So I'm going to wait on the bottom. Then I have 1, 2, 3, 4 n's. So times n to the 4th power. All divided by 4. And that's my final answer to that. So now we're dividing and canceling stuff out. We're not adding stuff together. Well, if we're canceling stuff out, we're kind of subtracting with the variables, aren't we? I mean, with the whole numbers, you simplify the fraction. Over here, we're minusing. That property, of course, right? Like, that's us using properties if we're minusing, aren't we? All right, here we go. I don't know, I feel like the divide should be in pencil. We got 39 is a coefficient and 52 is a coefficient. N to the 7th, n to the 3rd is equal to. So for these ones, you don't have to really rearrange too much because they usually line up. But here's what's really happening. I've got this divide going on, and I'm really thinking of 2 different things. So I'm just putting parentheses for just to see it. You don't have to do this usually. I'm saying what's going on with the constants? Okay. What's going on with the variables? Okay. Then I'm going to put them both together. So I'm going to deal with them separately and then do them together. Where's my green? Equals. Here we go. Well, I am dividing the top and bottom of this by 13 because, well, I know what the multiples of 13 are. 39, and I'm going to start, and I'm going to have my divide line. 39 divided by 13 is 3. And 52 divided by 13 is 4. Now I'm going to use my properties. If I'm dividing, the bases are the same, I'm going to take 7 minus 3. And now I'm going to clean it up and make it look good. This is 3, 7 minus 3 is 4, so we got n to the 4th power divided by 4. Two very different ways of doing it. Both ways definitely really good to know. The expanded notation is a great way, and the other one's just as good. It's up to you. We're going to do one more. A few more variables in there. All right. Okay. 12x to the 5th power y to the 4th divided by 2x to the 7th power times y to the 4th power. So, a lot of stuff going on, more than one variable. Here we go. And if you see something that you're like, isn't that gonna... Yeah, it probably is. So, keep it to yourself. Okay, 12. I'm going to pull 12 apart a little bit. I know 12 is 2 times 6. And if you look in the denominator, you know why I did that, don't you? X, 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 X. I got 5 X's. I got 4 Y's. All divided by 2. 1, 2, 3, 4, 5, 6, 7 X's. 1, 2, 3, 4 Y's. Okay. Let's do this. 2 divided by 2 is 1. There's nothing for 6 to dance with, so 6 is on its own. X divided by X is equal to 1. X divided by X, 1. 1. 1. 1. Hey, I'm out of X's on top, but I still got some in the bottom. That's okay. Y divided by Y is 1. Y divided by Y is 1. Y divided by Y is 1. Y divided by... I'm out of Y's. I'm completely out of Y's. So what do I put for an answer? What's left on top? Oh, 6 is left on top. Cool. Who's left on the bottom? Hey, those 2 X's are down there. And that's it. Life sucks, then you die. Like, y to the 4th, what happened to, like, look, they're both exactly the same. So they go away. All you're really worried about is what's going on over here. Because if you see this, you're like, the Y's are gone. There's nothing, the Y's not going to be the answer, trust me. Like, I've seen this movie. It's really bad. It's as bad as that Green Lantern movie that I really hate. I love Green Lantern, but that movie was horrible. Sorry, I digress. Let's use the properties. Let's write it up all colorfully, like this is 12, this is 2, this is a divide. Let's see, let's use green for x. X to the 5th power, x to the 7th power, y to the 4th, y to the 4th. What does it equal? Well, I'm just separating. I'm just trying to make it look good. And by the way, look over here. You're probably wondering, why did x go in the denominator? Why not put in the numerator? It's like tug of war. There's 5 x's up on top, and there's 7 x's on the bottom. The 7 x's, they're going to pull the 5 guys down below. And those 5 guys are going to fall on their 5 guys, and only 2 guys are going to be standing there like, huh, nobody fell on me. So there's 2 of us left. And then they'll dance. It'll be really cool. I think. 12 and 2. I can divide the top and bottom by 2. I would simplify by 2. That's going to leave me with 6. And I'm just going to start putting my pieces together. Oh, I take that back. You didn't see that divide line. X to the 5th, x to the 7th. I'm going to take x to the 5 minus 7. Because remember, the top number goes first, minus the second number. Y to the 4 minus 4. Well, 6 is left. He's not going anywhere. X to the negative 2, y to the 0. now we got, oh man, now we got like some exponent magic going on. First off, what's y to anything to the 0 power? That's 1. He's gone. 1 times anything, who really cares? Because that is the multiplicative identity. So that's done. 6 is still left. This mechanical pencil just doesn't like me tonight, I've decided. 6 is left, divided by. X is a negative exponent, so it's got to go in the denominator and become positive. So that's 6 divided by x squared. We are using properties like crazy. You got to be careful because all these different tricks, throwing them up in the air and waiting to see what comes down, it could just fall all around you. So take your time, breathe, and it'll be okay. Have a great night. See you next time.